but Mercedes-Benz is working to make it happen. The automaker recently unveiled plans for a revolutionary solar paint that could allow electric vehicles to harness solar energy directly from their exterior.
The race to dominate electric vehicle charging just took a wild turn. Mercedes-Benz claims it's developing a solar paint that could eliminate the need for daily EV charging. No plugs, no stations, just sunlight. The bold innovation has raised eyebrows across the automotive and tech industries. Could this be the moment Tesla's charging empire begins to crack? What happens when cars charge themselves while parked? What does this mean for Tesla's Supercharger network? And could this technology change the entire EV industry? Get ready for shocking claims, deep analysis, and the real reason why Elon Musk might be losing sleep over a can of paint. Because if Mercedes is right, the future of EV charging might not involve cables at all. Solar paint, the tech explained. At first glance, it might sound like something out of a sci-fi novel, painting your car and giving it the power to charge itself under the sun. But Mercedes-Benz has confirmed it's developing exactly that, a new type of solar paint capable of generating enough energy to significantly reduce or even eliminate daily charging for electric vehicles. The concept is bold, the potential is massive, and the technology behind it might just change everything we know about energy, mobility, and automotive design. The paint itself isn't just for show. Beneath the car's colorful exterior lies a microscopic layer, just 5 micrometers thick, made from photovoltaic materials. This is the solar layer. It's designed to capture sunlight and convert it into electricity that can directly power the car's systems or charge the battery. The entire painted surface of the car essentially becomes a sprawling solar panel, blending form, function, and energy efficiency in a way that's never been done at this scale. So what's in this ultra-modern paint? Though Mercedes has not disclosed the specific formulation, experts largely suspect that it would contain a sprayable perovskite, a greatly promising candidate in solar research with a bright future since high efficiency and low cost qualify for its greatest advantages. Laboratory tests have shown that perovskites can achieve over 25% energy conversion while being fabricated as working solar cells, coming into direct competition with conventional silicon-based solar cells. By their own calculations, Mercedes has proclaimed their solar paint to have an efficiency of around 20%, which is quite something when you factor in the sheer surface area presented by a car. To get it down on paper, under optimum conditions, a mid-size SUV with around 11 square meters of paintable area could generate enough solar energy to run the car for up to 12,000 kilometers in Stuttgart, Germany. In sun-soaked Los Angeles, the figure could potentially rise to £20,000, thus powering the average LA commuter's driving needs all day long without ever plugging in. Collect energy without any sunbathing angles at all. The paint captures solar energy even in light exposure while the car is parked, being driven, or stuck in traffic. This requires no bulky rooftop mount units or design compromises, as one has seen with some former solar EV concepts. A durability aspect is equally important. Conventional solar panels perish in bad weather, bird droppings, road dust, and UV. Mercedes, however, overcame this by putting the solar layer under the regular color paint of the vehicle. The top coat has been infused with nanoparticles, so the sunlight transmits up to 94% to the photovoltaic layer. At the same time, the paint protects the delicate material beneath from weathering. The end result is a solar collecting system that is practically invisible, yet works continuously. Furthermore, the paint weighs very little, only 50 grams per square meter. Economically speaking, it has no rare earth elements, no silicon, and no toxic materials, making it both environmentally friendly and recyclable. That further means it could be economically produced than the traditional solar panels, which makes it open for the wide adoption not only in vehicle lines, but also in other industries, such as architecture and aviation. This theory has staggering implications. Mercedes will not revive only its own product lineup with perfected technology. It could also change the entire EV ecosystem, in particular urban areas in which solar intensity is high and people have to drive only about 40-50 kilometers on a daily basis. More than just a proposition is an actual preview of a new kind of energy independence, one where your car becomes its charger and plugging into the grid becomes optional rather than necessary. While Tesla refines its plug-in charging tech, Mercedes may have just skipped the plug altogether. Mercedes' master plan. When Mercedes-Benz announced its solar paint initiative, it wasn't just revealing another flashy innovation for the showroom floor, it was signaling a long-term strategy aimed at reshaping the future of mobility. While the public remains captivated by the concept of a solar-powered car, what's unfolding behind the scenes is a highly calculated master plan. This isn't a quick experiment or a PR gimmick, it's part of a larger mission to push Mercedes to the forefront of sustainable, self-sufficient transportation, well beyond the current EV game. Mercedes' approach to innovation has always combined bold vision with deep research. The Solar Paint project is rooted in its Pioneering Innovations for the Car of the Future research initiative, a strategic platform that brings together in-house engineers, material scientists, and external partners in advanced photovoltaics. Their goal isn't just to make vehicles cleaner, it's to make them radically self-reliant. The solar paint is only one component in a constellation of technologies designed to strip vehicles of their dependency on conventional infrastructure. So, how do they plan to move this from lab curiosity to everyday reality? First, Mercedes is leveraging regional pilot programs. Prototype vehicles have reportedly been deployed in test markets with high solar irradiance, like California and parts of southern Europe. These vehicles are being fitted with early versions of the solar paint to measure performance under real-world conditions. Engineers are collecting data on everything from energy output to paint durability, and even how solar absorption changes over time with wear and tear. The significant aspect of this plan is that the paint integrates modularly with existing manufacturing lines. Unlike solar panels, this paint could be used without involving any redesigns. It is simply sprayed like any other automotive finish. Therefore, Mercedes does not have to undertake special solar casting for car bodies, a disadvantage that many solar car startups like Lightyear and Aptera have had to deal with. Instead, the solar paint may be used on any of the company's existing electric vehicle models without altering the design language or affecting production schedules. Mercedes also intelligently aligns its rollout with urban and climate data. According to the company, everyday commuter users in cities like Los Angeles, Barcelona, and Sydney could fulfill their rides 30 to 50 kilometers on a daily basis without a plug-in. Mercedes, for instance, already analyzes solar exposure maps and average driving patterns to inform its assessments regarding where the most significant and immediate impacts of such technology will be felt. Ideal launch cities are those that have mild climates and high solar potential. Importantly, the brand is counting heavily on its luxury credentials to lure early adopters. Instead of rolling out technology in a low-priced EV, Mercedes is said to offer it first as a premium upgrade for high-end electric models like the EQS and EQE. This casts solar paint as an enhancer of performance and the envy of many, two things Mercedes has cultivated in its selling tools. Presumably, the technology would proceed to knock down models as prices decline, widening the applications. Every conceivable aspect from the point of view of maintenance and repair has been addressed. According to Mercedes, a spot repair system for solar paint scratches exists in that the photovoltaic layer underneath will thus be kept intact. Solar paint is also said to resist the test of time set against the life cycle of the vehicle, and should improved protective top coats and UV-resistant materials come along, its life could be enhanced. The long game is clear. Mercedes does want to create not only electric vehicles, but also grid-independent ones. The idea is to reduce stress on public infrastructure, minimize the expenses associated with charging for consumers, and give the brand a huge selling point to attract customers as cities increasingly consider banning combustion engines. In pursuit of this larger goal, Mercedes is quietly investing in solar and coating research startups to secure patents and IP rights in order to lock in this first-mover advantage. The brand knows that this technology will not just influence vehicle engineering, it could also influence the entire EV charging economy. So if the paint works, does that mean Mercedes could outmaneuver Tesla without building a single new charger? What this means for Tesla. Tesla's biggest strategic advantage hasn't just been the cars, it's been the charging network. The Supercharger system, a vast and exclusive network of high-speed EV chargers around the world, has given Tesla owners the freedom to drive long distances without the anxiety of finding power. It's also been a major draw for new buyers who want peace of mind. But Mercedes' solar paint technology is threatening to unravel that entire ecosystem, and it's raising an urgent question. What happens to Tesla if charging becomes obsolete for daily use? The numbers are already telling a story. Mercedes estimates that, under ideal conditions, a vehicle painted with its new solar coating could generate up to 20,000 kilometers, 12,000 miles worth of electricity annually. That means for the average driver in cities like Los Angeles, daily commuting could be completely powered by the sun, without ever plugging in. For comparison, Tesla's typical charging cycle requires connection to a home wall charger or a supercharger every few days, depending on driving habits. In a solar-painted world, that routine becomes unnecessary. This shift doesn't just threaten Tesla's charging infrastructure, it challenges the company's entire value proposition. Tesla's investment in building over 50,000-pound superchargers globally has given it a monopoly on fast, convenient, long-range EV travel. It also locks drivers into their ecosystem, making it harder to switch to competitors without sacrificing access. But if Mercedes' solar paint becomes viable and widely adopted, especially on a cross-brand scale, the whole model could begin to crumble. An equally important psychological factor has been at play. For years now, range anxiety has been one major deterrent in turning people in favor of EVs. Tesla's answer to this fear was to install fast charging stations. Now, Mercedes offers another: get rid of the anxiety altogether by allowing the car to charge itself. Freedom for consumers, crisis for Tesla. The other hit is that it is solar paint that is not proprietary. Although recently it has opened up to some brands, Tesla's superchargers mostly remain inaccessible to other brands. That's where the possibilities come with solar paint. Any car maker can apply it to its models. Ford, GM, Toyota, Hyundai, and of course Tesla will be available for licensing or the development of similar tech. That wide openness could potentially flatten the battleground and change the discussion from who has the best charger to who needs a charger anyway. Another consideration to talk about is infrastructure investment. Governments, particularly in Europe and parts of Asia, have been investing for years in subsidizing the construction of charging networks to somehow assist with EV adoption. Then again, solar paint could shift the need for that infrastructure, especially in sunny cities where it gains the maximum effect. Future funding might turn from charging hubs to solar tech R&D, and great will Tesla finally think to build something that does not involve this kind of infrastructure. Internally, Tesla is aware of this pressure. Musk has previously called solar integration on cars not worth the surface area. This was before Mercedes released a paint layer just 5 micrometers thick, imparting almost no weight, without rare earths or silicon, and operating at 20% efficiency. Now, Tesla might be forced to assess this again as its rivals test similar tech or partner with solar coating startups. As Tesla doubles down on proprietary networks, Mercedes may have just invited every automaker to a new game with new rules. From hype to reality. Solar paint on electric vehicles sounds like something pulled straight from a futuristic sci-fi movie. A sleek car quietly absorbing sunlight and converting it into driving power. Mercedes-Benz's bold claim that its solar paint could power up to 20,000 kilometers per year under ideal conditions has certainly created buzz. But the question remains, is this groundbreaking innovation realistic, or is it just well-packaged hype? To answer that, we need to examine the science behind the paint itself. Mercedes hasn't officially disclosed the exact composition of the paint, but experts strongly suspect it's based on perovskite, a class of materials that has revolutionized solar energy research over the past decade. Unlike traditional silicon-based panels, perovskite can be manufactured into thin, flexible, and lightweight films that are cheap to produce. When applied as a sprayable coating, it allows energy-capturing properties to be embedded in surfaces like car bodies, without bulky panels or rigid structures. So far, lab tests with perovskite solar cells have achieved efficiencies up to 25%, rivaling traditional silicon panels. Mercedes claims a 20% efficiency for their paint, already impressive for something just 5 micrometers thick. And with a full 11 square meters of surface area on an average mid-size SUV, there's genuine potential to generate daily driving energy for urban commuters, especially in places like Los Angeles or Phoenix, where the sun is abundant. Still, there is the question of durability. Perovskite may survive in all weather conditions, even when cars themselves seem to abuse it with moisture, heat, and UV rays. To this end, Mercedes uses a transparent top coat that transmits 94% of sunlight down to the solar coating below. By guarding the solar paint from direct exposure, maybe this has addressed longevity among problems that seem to assail perovskite developers. This design, however, still poses real concerns. How well will this layer protect the cells in the long run against extreme weathering, car cleaning, road debris, bird droppings, and collisions? And will the paint be able to harvest energy without deteriorating very much? Some researchers have developed perovskite solar panels with a 30-year lifespan projected through advances in encapsulation technology. However, none of this has become commercially available, with a big impact concerning something as exposed and mobile as a car. Then there is the question of the actual environment. Although 20,000 km a year sounds impressive, it is obtained under ideal sunlight, perfect orientation, and daily use conditions. In cities with often cloudy, rainy, or lengthy winters, like Berlin or Seattle, there could be much less energy harvested. Mercedes admits as much, estimating in Stuttgart that only 62% of the driver's needs could be covered. That is still decent, but it signals that solar paint will never replace charging for everyone. Another practical question is about the manufacturing options. Applying such solar paint uniformly on an entire car body requires precision. Mercedes would have to ensure that their factories can upscale production without a compromise in quality and efficiency. Integration with existing paint lines, regulatory approval with respect to durability and safety, and training for repair and touch-up processes are all factors that contribute to the complexity of what first sounds like a rather simple paint job. Still, the last time people scoffed at solar panels, they ended up on millions of roofs worldwide. Could this be déjà vu? The future of EV charging. For over a decade, EV owners have relied on charging stations the same way gas-powered drivers rely on fuel pumps. Plug in, wait, and drive. But with solar paint now entering the conversation, particularly through Mercedes-Benz's recent announcement, a critical question is emerging. Are we looking at the beginning of the end for the traditional EV plug? Mercedes-Benz's solar paint technology suggests a radical shift from dependency on stationary power sources to continuous, passive energy generation. If a vehicle can recharge itself just by sitting in the sun, the daily need to plug in might soon feel as outdated as rewinding VHS tapes. This development doesn't just enhance convenience, it could reshape how we think about transportation infrastructure. Right now, EV charging presents several challenges. Urban dwellers without garages or driveways struggle to find reliable public chargers. On long road trips, drivers must map their journeys around Supercharger or fast charging station locations. Even with improvements in charging speed, the time it takes to recharge, especially on older EVs, remains a sticking point. The promise of solar paint is to bypass these limitations entirely, offering a silent, effortless form of charging that happens anytime the sun is shining. Mercedes estimates that, under ideal conditions, solar paint could generate enough energy for up to 20,000 kilometers, 12 to 427 miles, of driving per year in sunny regions like Los Angeles. For many drivers, that's more than enough to cover average commuting needs. In essence, your car could power itself while parked in a driveway, office lot, or even just sitting at the curb. But for light-medium users, this may create a plug-free life. No cords, no looking for free chargers, no worry of leaving the car plugged in overnight, just a self-sustaining loop of daily commute from driving to parking and charging through sunlight. This mode, when adopted widely, disrupts not only EV habits, but also entire industries. Auto manufacturers of charging stations, provided electricity utilities, and commercial property developers have sunk big bucks into building such a plug-in infrastructure. But a world where vehicles charge themselves probably then topples the long-term business case for these investments. Tesla is perhaps most vulnerable because it has built a huge advantage with its Supercharger network. Should solar paint undercut even a fraction of that demand, Tesla's most strategic asset could quickly slip in value. It also raises questions regarding the future role of the grid in electric vehicle charging. Today's concern is, power grids can keep pace with the upsurge in electric vehicle adoptions. On the other hand, what if these many vehicles begin supplying their own electricity? In that case, the demand curve might flatten or even drop. Such developments would relieve utilities, reduce infrastructure costs, and perhaps make EV adoption more feasible in remote places where grid upgrades could be cost-prohibitive. Will other automakers race to catch up with Mercedes, or will this technology fade into the background? Just another unfulfilled promise? Let us know in the comments what you think.